Good morning, everybody, and welcome to session Dev 301, Maximise .NET with C++ for interop, performance, and productivity. Please allow me to introduce myself. I'm Angel Hernandez. It's Angel. Angel is angel for Spanish, but it was a silly joke, sorry. But yeah. You know, I've been here in Australia for 3.5 years. I'm originally from Caracas, Venezuela. And that's been the hardest thing to overcome, how to teach Australians to pronounce my name properly. Hey, Angel. Hey, Angel. But anyways, I'm a Visual C++ MVP, and C++ is one of my passions. I'm passionate about engaging people, presenting, writing technical articles and papers and all that kind of stuff. And I think that I prepared a couple of demos that might be of your interest. So without any hesitation, why don't we, by the way, I work for Avan Australia, and I'm based in Sydney. So if you ever want to catch up, practice your Spanish a little, or you want to talk about Windows internals, C++, C#, CLR, or whatever, please feel free to come to get to me after the session, and I'm more than happy to discuss a bit more. So please raise your hand. Is there any C++ developer in the audience today? Cool. SharePoint developers? Is there any SharePoint developer? Oh, Steve. Because I got a demo which is about SharePoint and C++. It sounds weird, but yeah, it's possible. So let's get started. Oh my goodness, what is that? It looks like the matrix to me. Yeah, well, it's the matrix actually. But it's the matrix with C++ keywords like null pointer, mutex, lambdas, volatile, and stuff like that. Let's just think for a moment. What about if the matrix was real? I'm pretty sure that if the matrix was real, it would have been written in C++. Why? Yeah! Real-time processing is a neural simulation real-time. And that's one of the benefits of C++ real-time systems. But let's skip the matrix for a second, and let's proceed to the agenda. So our agenda for today is what's going on with C++ these days. There's been a lot of stuff since Microsoft released .NET back in 2002. However, with the upcoming release of Windows 8, there's been a lot of noise about native code development once again. C++ is the champion of speed. Who disagrees or agrees to that statement? Please raise your hand if you agree to that statement. Cool. Best situations for C++. C++ CLI. CLI stands for Common Language Infrastructure. Commonly used techniques for interop. Native code without sacrificing .NET performance. C++ in the cloud. Introducing C++ AMP. Basic elements of C++ AMP coding. Cool. C++ AMP at a glance. So what's going on with C++ these days? Well, the new standard was accepted by the ISO committee some days ago. To be honest, on August the 12th this year. And what it was previously known as C++ OX now is C++ 11. C++ out of the box provides us developers with native support for multi-threaded application, even though we've been doing it for a while. Now we've got mutexes and some other synchronization mechanisms that's coming out of the box and supported by the runtime. Newer smart pointer classes, algorithms, and containers. Lambda expressions, automatic type deduction, and lots more. So C++, it's been the workhorse for the last 20 whatever years, and still up to date, especially with this upcoming release of the new standard. C++ is the champion of speed. Cool. Well, since we're in Surfer's Paradise, I thought that it was convenient to have a surfer on my presentation. So Google has recently conducted a research with, where they were comparing the performance among these 4 languages: C++, Java, Scala, and their own language, Go. And guess what? And the winner is C++, which is not a novelty or is not new a new thing to us C++ developers. And if Google says that, it's going to be true, right? He's always right. So, Go Speed Racer, Go C++. I'm going to jump to my laptop, and I'm going to start demoing something here. Cool. At the keynote, Adam Spencer, that was his name, right? The guy who was the host. He mentioned something about prime numbers. What I got here, it's the implementation of 2 algorithms. One of them is to count the Carmichael numbers, which is not a prime number, but a pseudo-prime. And the other one, it's about performing loops and multiplying. And let's compare the performance of C++ compared to C#. So I'm going to start, what I do is, can you read the font or should I increase it? Is that okay? So this demo here, I populate a vector of integers, and then all I do is I execute a lambda here to verify if the number I'm processing is a Carmichael number. Excuse me, I need to have some water. I execute this in serial, and then I implement the TPL, or Task Parallel Library, and I do it in parallel. So let's run it. This is the C# version. So it's going to take a while, and I'm going to show you at the same time the CPU usage. And then after this, I'm going to execute it, or I'm going to run my C++ demo. Is there any questions so far? Okay. That was in serial. This is in parallel. As you can see, the CPU usage. I'm using, this is an i5, which has 2 cores, and 2 other are hyper-threaded, 2 are virtual, and that's why I get to see 4 CPUs. This one is using the TPL. As you can see, I'm using the CPUs in a better way. Come on, C#. Cool. I'm going to leave that open, and I'm going to run my, where is it? Sure service, no. My C++ version, similar. All I do, I execute it in serial, I count the Carmichael numbers, but in this case, I'm using C++. This is the new syntax for lambda in C++ 11. And after that, instead of executing TPL, I use PPL, which is the parallel patterns library, which is for C++. But let's run it. And there's another demo as well. So please bear with me. This is going to take these demos. If there's any question. Yes, sir. Definitely. That's executing in serial. That's the PPL working. As you can see, the CPU, because if you have a look at the CPU usage, I'm not optimizing any C++ code. It's like the same algorithm implemented in both languages. Yep. No, no switches, not at all. Is it, your question is, are we going to have a new version of the compiler? Yeah, it's available in 2010. Yep. So that's the result. Let's jump back and have a look at the previous window. So it was similar. I'm disappointed. But, hang on. There's another demo, and we're going to tell the difference here. The difference here, all I'm doing, let me jump to, where is it? The speed test managed program. This guy, all it does is I multiply. There are 4 arithmetic operations, or basic operations. Addition or subtraction, multiply, and division, being the latter, the more expensive one. In this case, all I'm doing is I'm going to loop 1,000,000 times, and I'm going to multiply 100 times, which is this one. So I'm going to run the C#, my bad. Let me set it as default project. Yep. And let's select the other one as well. Cool. So C# tab started. Cool. Same algorithm, no optimization, no switches for the compiler or anything similar. It's just I'm looping. Okay, that's the C++ version. And C# is still going. Release mode. Mm-hmm. No, the whole is default switches, just release mode.
Right, the release mode has default switches.
Yeah, default switches. Yep.
Right, so do you know whether or not the default switches for the C# for the JIT compiler is the same as the compiler for the native?
Yeah. However, I'm using the default out of the box whenever you select from the project properties. I'm not adding any additional switches. As you can see, the C# executed in 46,956 milliseconds. The C++ version, 18,000 milliseconds. There's an explanation for this. Managed code provides us with, has a lot of security checks and performs a lot of stuff. Actually, for this simple application, it loads like 55 DLLs. And it's not the same amount of effort for me to lift up this bottle empty as if it was full. And that's one of the differences. C++ loads just the runtime library, and that's all pretty much. So, in the meantime, I need to start these 2 VMs for my next demo. And let's continue with the presentation. So we saw Angel presented to us a demo where the generating or counting the Carmichael numbers, it was the outcome of the result was similar. However, there was another demo, and C++ outperformed C# code, the same algorithm. Having said that, I wonder, what are the best situations for C++? Graphical and audio, workstation software, large-scale productivity, applications like Adobe Photoshop, legacy code bases, real-time system. That's why I put the slide about the matrix, because if the matrix was real, I'm pretty sure that it would have been written in C++ because of the real-time processing. Anything involving extreme numerical computation. Like I said before, there are 4 basic operations, being multiplication and division, the most expensive ones. Large-scale data storage and retrieval, device drivers, and so forth. So if you want to squeeze and take the most out of your hardware, memory, capabilities, C++ is the guy you have to use. C++ CLI. What that CLI stands for? Question? Any ideas? What was that? CLI, CLI? No, it's close, but no. Common language stands for Common Language Infrastructure. So it's C++ code executed inside the .NET framework. So it's a binding between the standard C++ and the CLI. Allows developers to reuse their native code base with saving the agony of rewriting the whole thing for the .NET framework. It's designed to be the lowest level language for the .NET framework. They can leverage their existing knowledge about C++ and use that knowledge in conjunction with the .NET framework. Allows developers to leverage the latest managed frameworks. And this is a very important bit, marshalling made easy. For instance, I don't have to be marking sections of code with unsafe or anything like that. I can have pointers and convert, for instance, a pointer of W*, which is Unicode, to a string very easily. Okay, so C++ CLI, the best of both worlds. So I'm going to switch back here, and I'm going to explain this demo a bit more. What I got here are two VMs. One of them is running SharePoint 2010 on Windows Server 2008. And the other one is running Windows 7, which is a client. So what is this demo all about? Okay. This demo, it's about reusing the existing APIs provided by the operating system to create or schedule tasks on a remote computer. Plus, at the same time, this web part has dual functionality. I can also start, stop, or restart services from SharePoint from a web part on a remote computer. So let me jump to this one as well. It's going to be available for the next version of Visual Studio. I don't know why, but it was one of the program managers for Visual C++ or something who made the decision about removing the theme for 2010. And we community, we were so upset, and now it's going to be back in 2020 in vNext. So I'm going to firstly, okay, I had to write this demo using Visual Studio 2008 because by the time SharePoint was released, the version of the framework was 3.5, and Visual Studio 2010 doesn't, the C++ compiler doesn't allow me to compile to 3.5. So that's the main reason for it. So it's loading here. Let me, okay, cool. Let me maximize this guy.
The current version of C++ CLI will only target, like Visual Studio will only, in 2010 will only target
4.0, yeah. Sorry, sir? What was? I wish I knew. That's something that we have to, compose an email and send it to the program manager at Microsoft. To be honest, I really don't know. Cool. So let me launch my portal. At the same time, I'm going to the control panel because I need to get to the scheduled tasks. So that scheduler. Let me get rid of this one. This was me last night testing my demo. And okay, cool, here we are. It's SharePoint. It's going to take a while because I'm loading my site for the first time. But if you have any questions in the meantime, please feel free to ask. Yes, sir.
In the page 2, you had best situations for C++.
Mm-hmm.
And one other thing was real-time. Actually, what does real-time mean in that situation? Is it like we're talking about real-time systems, or is it?
Real-time system. Let's say that you have this biometric device or this device connected to something, and you want to process that information in real time.
Is it the hard real-time systems here?
Yeah.
Because there is a, because when you talk with this next talk about Azure, in which somebody is doing a stock trading or something, or 200,000 transactions per minute
Mm-hmm.
in C# and all. So that's a different sort of real-time than the one you're talking
Yeah, actually one of my demos is about hosting a native DLL in Azure. So we'll get to that point a bit later. But yeah, you can do it as well with C++. And it's quite funny, right? Because with the common release of Windows, I'm pretty sure that the API will expand and grow. And some of the features, unfortunately, that the operating system provides, they are not exposed by the .NET framework. So it's better to have a better bit of understanding about what can I do, what can I achieve and accomplish with native code. So this is still loading. In the meantime, let me walk you through the thing, right? So the funny thing is, almost everything that can be done with C# using the .NET framework can be done with C++, literally. The thing is, for instance, for some reason, some of the templates for creating the projects, they are not available. However, you can do it by yourself. So if I go here, right, all I got is it's similar, as you can see, C++ code. I import my namespaces from the .NET framework, the ones I want to use. Actually, I have a template which implements a template, right? I got my private, my public, and everything here. I can even use attributes in the same way I do it with C#. I got, for instance, this class here, which is the grid template. I also got a progress template, which is because I'm even implementing Ajax. Have you ever wondered, well, I would like to have this C++ application, web-based application, and I would like to implement Ajax. Is it possible? Yeah, it's possible. Most of the things, and this is something I realized and I found out, I've been dealing with computer for some time now. Most of the things on a computer is doable. I would say that 95% of them. The other 5% is because it's whether we don't know it, how to implement it, or we don't have the information about how to get it done. But everything is possible. So back to the thing. This is the web part. I declare this is my header file, my .ch. And if I go back to the implementation, let me go to the web part itself, right? Initialize grid, web part body. This is where I inject my Ajax controls and stuff. The funny thing is, it's quite funny, right? Because in .NET, most of the people, they don't like C++ because of pointers, right? But have you ever realized that everything in .NET is a pointer? Whenever you pass something, it's a reference. When you get an old pointer exception, it's because you were referring to something which was pointing to nowhere. So if we take that into consideration and we think about, okay, everything is a pointer, we just have to replace the arrow operator with a dot. And it's the same thing. So let me just check if, okay, cool. This is my website. Go to my tester page. Cool. So like I said to you before, this web part has dual functionality. From this section here, I'm able to retrieve the computer names from the network, and I populate that drop down there. And this one here gives me, on the right, gives me the status of the Windows services running on that box. For the sake of the exercise, I'm going to create a task from my SharePoint web part on my Windows 7 computer. Millisecond from midnight, let's say this number of milliseconds. And let me show you that I don't have anything here. I'm refreshing the thing, I don't have anything, right? Go back to the thing, and let's say, well, I want to execute the calculator because I would like to do some math, whatever. Submit. Bless you. That's my Ajax control. That was it. If I jump back to my Windows 7 computer, voila. I didn't have to implement any WMI or Windows Management Instrumentation. All I did was to make a couple of API calls provided by the Win32 API to make it happen. And if I go back to the properties here, you'll get to see that the actions, you're going to start the calculator. How cool is that? Okay, now let's go back to the other remaining bit of the demo. Okay, let's say, let me open the Services Management Console. And I'm going to start this human interface. It's stopped, right? So, human interface, whatever. Yep, stopped. As you can see, I was able to create a template and apply the template to my web part, to my grid, actually. So, okay, human interface, device access. So if I come here, these are the actions, the possible actions that I can perform on that service. I would like to start it, submit it. If I come back here, it's running. So think about the possibilities, about what you can achieve, how much functionality the operating system provides, which is not available through the .NET framework. And let's say that my company policies is, okay, all new development has to be based in .NET. Cool. However, we also got some legacy DLLs and some libraries and APIs that I would like to leverage and use it in conjunction with .NET. Well, we got C++ CLI to make it happen. Yes, sir.
Are you saying that this cannot be done through C#?
Yes, it can be done, but let me show you something. That's a very good question, actually. The thing is, if I go to this structure here, it's about pointers, all that kind of stuff, linked lists, and etc. If you want to make it happen, or if you want to get it done with C#, you have to rewrite all those dependent structures in order to make the function, the underlying Win32 function, work. Otherwise, it won't work. So if you take into consideration, okay, I'll have to start rewriting. And there's another one which is awesome. A good example, right? So, let me, please bear with me for a second. I think that this is the one. This one takes a pointer to a buffer of bytes or something. Yeah. That's a pointer. If we want to make it happen with C#, it's a bit error prone, I would say. But yeah, it's possible. Everything, like I said before, everything is possible with a computer. Or, well, 95% of everything. So let me go back to the source code. So all I do is, for instance, I my servers on the network. I populate the drop-down. And this is something I want to show you. I got a new char here. And for each new operator or whatever dynamic memory allocation you're doing, there's got to be a delete. And this is not only, this rule does not apply only to C++. A lot of people says, no, managed code's perfect. It's not perfect because you don't have to be worried about all the plumbing and memory management and stuff. However, I found very nasty memory leaks in .NET. It's not because of the framework, but the implementation. No, the garbage collector will take care of that. And the golden rule is, if there's an object which implements a disposable, please, for the sake of your program, dispose of it. In my humble opinion, and this is my personal opinion, managed code doesn't mean that the developers have to be lazy. Memory leaks will occur, but it's less likely that will occur at the same frequency as it does with a C++ application. At the end of the day, as developers, we have to have common sense. No matter if you're writing VB, C#, C++, if you don't have common sense, it's a matter of, come on, dude, what are you doing? Question. Is there any questions so far about this demo? Questions so far about the session? Yes, sir.
On the language, on the C++ CLI,
Yep.
like is using the same syntax for generics and C++ the same syntax for templates. So how does it?
That's quite funny because templates, they've been around before generics. So let's say that C# has borrowed quite a few things from C++ and some other languages. I won't mention, but yeah, it's the same syntax. Yes.
Does the two things coexist, the templates and generics? Because generics are not templates.
No, but the implementation is a bit similar. Well, no, it's not, but how would I explain this? We can discuss that a bit later. The way we use it, or from the .NET developer, that's the perception. It's similar. That's what I meant. But it's not the same thing, obviously.
You wouldn't really have that application wouldn't want you to delete it with it if you're using smart pointers.
Yep. This is just for the sake of the exercise or the demo. By the way, you feel free to download the slide deck and demos from my blog at the end of the session. So is there any other questions so far? Cool. Let me shut this down and shut this down. Cool. Let me shut this down. Otherwise, I'll get confused. There's so many windows. Cool. Let's go back to the presentation. So far, session recap, we've talked about best scenarios and best situations for C++. We talked about the performance and all of those benefits which C++ provide developers with. We talked about C++ CLI. Now, let's talk about a bit of interop. So the commonly used techniques for interop are, straightforward pinvoke, which is using the DLL import attribute and marshal-as attribute. Com interop. Quick question to the audience. Is com component object model dead? I didn't hear you. No. Why not? A good example of a com-based application. Office. That's right. Com is a great technology. The issue is some irresponsible developers don't use smart pointers, and that's error-prone and all that kind of stuff. But the technology as such is very good. Actually, with a new release of Windows, the API introduces some more COM functionality into it. So it's straightforward pinvoke through DLL import and marshal-as, COM interop. Once again, CLI wrapper class. If you want to be fancy about reflection and start rewriting your own IL, you can use reflection emit and make it happen as well. Native code without sacrificing .NET performance. Things to consider. Mode transition. Like the operating system has kernel mode and user mode, this is managed code and native code. We have to be wary. We have to be, how would I say this, conscious about how we move and transfer data from the managed world into the native code and vice versa. Marshalling the data to move across the boundary. Marshalling is computationally expensive, and the more data you move back and forth from these boundaries, the more expensive it becomes. Ways to transition code and data. Traditional DLLs, you just have a DLL and export some functions. COM-based DLLs. Marshalling. Implement any IPC mechanism. IPC stands for inter-process communication. For instance, a memory map file or a name piped or something. Questions so far before I jump to the demo? Yes, sir. Yep. Is there any question? Yes, sir.
When you've got the mode change in the C++ CLI, is that the same cost as marshalling between C# and C++?
Yeah.
Exactly.
Yeah. The only difference is that you don't have to be worried about managing pointers, marking code with unsafe, and rewriting structs and all that kind of stuff to make a call to a Win3 type function. But yeah, it's running on top of the CLR. Is that it? Can I? Oh, okay, cool. It's okay. So the next demo, it's something I wrote. Where is it? It's this guy, Memory Inspector. What is a memory inspector? Well, I'm a big fan of Windows internals. Oh, sorry, you're not. Yeah. What's the memory inspector? The memory inspector is it's quite cool. You can download it from the Visual Studio Gallery because it's an add-in for Visual Studio. But the memory inspector allows me to see stuff like, I would like to see the allocations for, I don't know, task manager, for instance. Yeah. So the core of this application is a 64-bit DLL, which makes calls to some Win32 debugging libraries and functions. If you hover, however, the UI is provided by WPF. If you hover on top of the libraries, you'll get to see the module, the size of that module, and the entry point, etc. And let me grab this one. There's also a color key to know whether it's a managed assembly or that library is sitting inside Win32 or something. And you can also get to see that's WPF. However, what I'm doing, and that's something I would like to show you when I'm running you through the source code, is that the calls are made to this Win32 DLL. So for instance, these are the allocations by NTDLL. I can get to see the base address, the region size, the protection, the state, and the type of allocation. But most importantly, I can take a dump, literally, memory dump. Don't get me wrong. Don't get me wrong, a memory dump. And most importantly, I can get to see, if you're curious about, because I think that everything starts with curiosity. If you're a curious person, you'll get to learn and learn. And the more you learn, it's quite interesting. The more you learn, the more ignorant you become. Because, oh my goodness, I didn't know that that was the way that thing worked. So from here, I can also get to see the exported functions and symbols.
Can this do like dump domain functions, like that you get with debugging?
That's a good question. There's a roadmap for this tool, and the next step, if I have the time, is to implement the SOS DLL in order to dump and debug managed code assemblies. I'm working on it. So for instance, these are all of the functions exported by nt.dll. And from here, I can just right-click, search online, boom, and I'll get to the documentation. Cool. So let me close this down and let me show you how I did it.
How does it know which of the allocations are being done by each TLL?
Yep.
Was it specific to NTTLL that you could track the allocation?
I do it on a module per module basis.
Right. How, my question is, how does it know which code, like code in which TLL form that allocation?
I'll show it to you.
Is it in the heap these days? Is there a point?
I'll show it to you. I'm getting there. So, like I said before, that I'm adding. Actually, I can launch it from here, from Visual Studio. So I'm using the Visual Studio SDK. If you get to see this guy here, it's a Visual Studio window. How come, Angel? How is it possible that you're executing a 64-bit application inside the Visual Studio IDE, which is 32-bit? How can I make that happen? Well, theoretically, it's not possible. But what I'm doing is I'm changing the parent of the window to be the frame inside Visual Studio. And the Win32 API takes care of that for me. So yeah, this is my application once again. Let me close this and run you through the... So is that the font size okay, or do I have to increase it a bit? So back to your question. I have develop main, execute. So I take the image name, I call execute helper and everything, and from execute helper, so we're talking about the memory allocations, right? Get allocations. So get allocation helper. I use virtual query X. And all I do is I transverse from the starting point, from the base address of that module to the end. That's how I accomplish it. And if you haven't seen it, if you haven't noticed it, what's my own IPC mechanism that I implemented? Easy. A well-formed XML. That's what I'm returning back to the client or to the one consuming the DLL. Having said that, it can be consumed by any other program, like a Java-based or .NET-based, like in this case, or native code application. So what I do is the representation for the cool thing about, before I get there, the cool thing about strings in .NET is that you don't have to do all that marshalling. Every single string in .NET is an Unicode string. Having said that, if you return a Unicode string from the native world, you don't have to do anything or any marshalling. However, the way I did it was, if I go to memory, that exchange, this is C# code. Here I'm calling my library, and module path. Okay, execute, which is the entry point. I just pass in the process name, and I need to pass in a buffer of wchar, which is my string, which is going to be a well-formed XML. I pass in string builder. At the end of the day, I'm just passing references. Like I said before at the beginning of the session, everything in .NET is a reference. So if I pass that, that's equivalent to execute, to a pointer, a wchar pointer, which is Unicode, a white char character. How cool is that? To mix technologies. I love it. Questions so far?
It looks like you're not using any MFC in that code. Does MFC break what you're doing in any way? Or
No? Mm-mm. Not at all. Any, yeah. Any other question? Let me show you something else. And see, all I'm doing is I create or I write this XML structure, which is returned back to .NET. But the thing I wanted to show you is the lambdas syntax. I think I showed it to you before, but lambdas, where are you? Here. So this is a lambda. I'm using a container, which is a vector. Yep. And I create a lambda, which is this guy. In this case, I'm capturing this variable here. And all I do is I loop through that collection, collect information of whatever it is, chuck it into the XML, and bam, I return it back to .NET. Cool. So back to the presentation once again. Just, oops. Let me go back to the preso. Yeah. So recap. We talked about benefits of native code, benefits of C++, what's coming, the new standard, interoperability, C++ CLI. What's next? The cloud. Look at the cloud, Luke. Everything is moving towards that direction. That's the trend, right? So yes, we can leverage the power of C++ with Windows Azure. Yes, we can do it in a similar way to what we do it with, like I showed you before. Windows Azure, let's remember one thing. It's running on top of Windows Server 2008, R2, whatever. So yeah, we can do it. Microsoft refreshes C++ for the cloud. However, it won't be available for this version of C++. And introducing now C++ AMP. What is it? It's part of C++ and Visual Studio vNext, STL-like library for parallel patterns on large arrays, built on Direct 3D, and most importantly, it's an open specification. Let's say that you have this calculation and you would like to execute that code on the GPU. Easy, you can get it done with C++. Why? Well, let's say that I'm writing this CPU-consuming graphic application. Well, I want to distribute the load, the workload between the processor and the graphic card. I can get it done. Productivity and portability. You don't have to learn a new language because it's STL-like. So if you have worked before with the standard template library, you'll be just fine. How does it look? Well, firstly, you have to include the amp.h, add the namespace of the concurrency namespace, add arrays, and here the restrict, what's the laser? I think, yeah. I'm saying, I'm instructing I'm telling the thing, well, if there is a Direct 3D capable device, just execute that code on the GPU. How cool is that? So for instance, unfortunately, this technology is still under development. I had a couple of conversations with the program manager for the C++ AMP, and I couldn't get my hands on AMP as yet. So all I'm going to walk you through is the way it will look like. So for instance, this is a serial loop test. This is the way it will look, or it will be written in with AMP. So basic elements of a C++ AMP coding. In this case, in this example, I'm adding arrays. Parallel for each. Parallel for each is available right now. If you got Visual Studio 2010, you can take advantage of some of that functionality. Has anyone here in the audience used PPL before? Pattern Parallel Library? You can use Parallel for each. You don't have to wait for the next release of Visual Studio to be released. No, it's available, Parallel for each. So, okay, back to the sample. Parallel for each, execute the lambda on the accelerator once per thread. The grid, the number and shape of threads to execute the lambda. Restrict direct 3D. Tells the compiler to check that this code can execute on direct 3D hardware. Index the thread ID that's running the lambda. Array view and array view variables. And that's C++ AMP. I'm looking forward to it to start playing with it. I love being an early adopter. It's so cool. Questions so far?
What happens if there isn't suitable hardware?
It will execute on the CPU. Yeah.
So that, sorry, that square brackets with the equals, that's new syntax, yeah?
That's a lambda, yes.
Before it was you coded lambdas and
No, because in this case, I'm not capturing the variable by reference. It's just a copy. The ampersand is by reference. So if I make changes to the variable inside the lambda, it will reflect that change outside the scope of the lambda.
If there's no GPU and you write it like this, will it execute?
Yes, sir.
Will it execute as fast as if you had?
No, no way, no.
Can you run arbitrary code on the GPU? Presumably it's only certain kinds of instructions, right, that will run on the GPU?
I couldn't hear you properly. What was that?
What kind of instructions will run on the GPU?
This code. I mean, whatever you enclose between the, for instance, in this case, a for each.
So anything, you can run any code on the GPU?
Yeah? Any other questions? Cool.
Can I just expand on that last question? Like trigonometry, can I do logarithms in the GPU? Could the GPU do anything?
Yeah. The thing is, and this is quite funny, right? The only software which takes advantage of the GPU are games. Are games, right? But what about if we have CPU and we can leverage and use the GPU at the same time? Can be more productive. For instance, my CPU can be doing something else and the GPU can be processing something else at the same time.
Can I take that last question to death? So could you have a print statement, an IO stream within that?
I don't think so, because in this case, it's about structures, managing data. However, I don't know.
Yeah. So I mean, there's no way that a GPU is going to do decent IO.
Exactly.
So does the compiler do anything like that restrict keyword?
Yes.
It will give you compile errors, will it, if the stuff within what you're passing within that restrict block is unable to be executed on the GPU?
I'm pretty sure that you'll get an exception. Like I said before,
Runtime.
yeah, runtime exception, most likely. Like I said before, however, that's my personal opinion, because this technology is still under development. It can change, so yeah.
you've got a tool similar to Task Manager for the GPU.
Visual Studio VNext will come with one tool built in, yeah. So, demo, auto. Auto is a new keyword, which is like var in C# equals Windows Azure lambda void whatever C++. It was supposed to be a silly joke, by the way. So, let's go back to the demos. Come on, is it 2 or 1? Help! It's the West. Ah, that's better. Thank you. Well, that's my avatar. That's Shrek, and Shrek is wearing my office pass. So cool. So what I got here is okay. I created. Do you remember the East Carmichael whatever we demoed at the very beginning? All I do here is let me. In a similar way, right? Same algorithm, but I expose this functionality as external. I export this function pretty much. In the same way, I make calls with the memory inspector. I do it in the same way. I just pass in on stream builder. I write a well-formed XML, which is returned back to .NET. So same algorithm, and I also got two roles, a web role, which is based on ASP.NET, you know, the front end and stuff, and the worker role. I'm using at the same time, if I go back to the worker role, this is where the fun happens. Okay. So in a similar way, you know, I'm implementing the DLL import attribute, calling my DLL, get Carmichael numbers. I pass in a stream builder. And this is very important because in native code, we don't have something like the stream builder.length. So I better make sure to let my native DLL, which is what's the maximum size for my string. I have a queue, and I communicate. What I do is the worker role calls the native DLL, chunks that information into a queue, and that queue is read from the web role. Okay? So this is where I create my stream builder. This is where I'm calling my native DLL. All I do is I create a message, I chunk it into the queue, and that's it. So let's push the button. Actually, I deployed this solution to Azure this morning, and it was working okay. But I had to. No, it's down. I need to get to the console. Please bear with me for a second. Yep. Just 1 second. Don't look at my password. Cool. So, okay, if I open up the emulator here, I can get to see two roles. This is my worker role here. I haven't added anything to the queue yet because when I do it, I write something here like I added something to the queue. So if I run the thing, I can tell what it's doing. Yeah, it's getting the Carmichael numbers, and it's running the paddle thing. Yeah. Yeah, I can tell by the usage of the CPUs. Okay. Let's go back to the web front end. Voila. I did all the processing, the numeric calculations, and everything in C++, and I returned a well-formed XML to .NET. And the mechanism I'm using to pass information from one side to the other is just a queue. So, sorry?
Was the task manager that you were showing on
No, that's my physical. That's the host.
right.
Yep. So this is suspended. This is the deployment of the same solution.
You just said, there we go, we're doing a parallelization right as, all the CPUs sort of
So let's
went up.
wake up, Sleeping Beauty. Come on, wake up, wake up. It's the same solution. One thing that you have to be aware of is that whenever you are consuming and using a native code DLL, you need to make sure that you are deploying the dependencies. And very quickly, if I users Angel.Hernandez desktop set it cd ticket demos. Come on, dude. I better stop the other thing. Stop it. One quick way of finding out the dependencies is, go away. Please bear with me for a second. CD cloud. Managed. My Azure service. Bing, I think. Tier debug. I hate this path. So long. My Azure service. CD, where is it? It's gotta be, please bear with me. My Azure service. It has to be debug. Where is it? Okay. It'll be quicker to use Explorer. That's why I'm not going to mention any operating system, but that's why Windows rocks. TechEd, demos, cloud, managed, debug. Where is it? x64, bomb. So I'm going to grab this guy, I'm going to copy it to ctemp. Yep, a lot easier. So in order to find out and get to know the dependencies, you just do something like dump bin my DLL dependents. And you'll get to know kernel 32 will be, is going to be on the Windows Azure server and on the VM. However, you need to deploy with your solution these two DLLs. Otherwise, your solution won't work. Dump bin is part of the Visual Studio SDK. It's very useful, actually, because dump bin, you'll get to see the exports. For instance, if I want to see the exports of that guy, I can get to see my DLL.exports. I can get to see the exported functions. I can get to see a lot of stuff, useful information. So, okay, back to the presentation. Come on, dude. It's not working. Help! I need somebody, help! It's not going back to the presentation for some reason. Thank you. So that was my demo about C++ in the cloud. Session objectives and takeaways. There's no universally a better language, right? C++ is robust, is scalable, and amazingly fast. Direct access to hardware and memory. Managed languages for rapid application development and business applications. C++ provides with out-of-the-box native support for multi-threaded applications with the new standard. Develop memory or CPU-intensive components in C++, and consume it from any managed language. Related content, a link to my fellow Visual C++ MVPs, my blog, Bonafides, the blog of the C++ team. If you want to find out or learn a bit more about C++ AMP, that's the program manager for the C++ AMP, Daniel Moth. And the paper about, the Google paper about performance and all that kind of stuff in languages, that's the link, so you can download it from there. Resources, take it online, MSDN, etc. Questions and answers. Is there any question answer? They're kicking me out, sorry. Well, we can talk a bit, yes.
Just quickly, does the C++ and CLI work with the .NET Compact framework?
No, I don't think so, no. When I touch mouse, please fill out your evaluation forms and all that kind of stuff. If you do it, it will help us to improve the tech ed for next year. And by the way, very quickly, please engage your community. Get involved with community. Next year, I would like to come into tech ed, and I would like to see any one of you presenting here on stage. Please do it. Get rewarded. Thank you. Thanks for your attention, for coming. Enjoy tech ed.